Good afternoon, guys, or at least it's afternoon for me. I just wanted to do a couple of example problems for what you need to do for your assignment for our remote day on Monday, the 19th. And I'm just going to go through a couple of examples of the process and what we need to do. Most of it's very familiar, stuff we did on Thursday in class, but we're adding an extra layer to it and we're thinking about Newton's second law. So just as a reminder, Newton's second law is the fact that our force is dependent on both our mass and our acceleration for our object. So I'm going to write it down here actually. That means that our net force is equal to mass times acceleration, F equals ma. That is our formula. That is what we're going to use today. Let's go ahead and start this problem. You can just email me with questions at the end. Our first scenario is a person is pushing a 39.2 Newton or 4 kilogram box along a rough floor, rough means there's friction, with a force of 55 newtons. The force of friction between the box and the floor is 37 newtons. What is the acceleration of the box in the x direction? So that means at the end we got to solve for acceleration. Let's start with our free body diagram. So we know we have a force applied. I think my camera's inverted. We have a force applied, which we're going to draw to the right. We also should have a force Newton force gravity because we're on a surface, and also we're on Earth, and it tells us that we have friction because it's on a rough surface. We gotta have friction too. So let's go ahead and make our free body diagram. So I know I've got a force normal, a force gravity, a force applied, force friction. Okay. And we're going to need labels for that. So we'll go ahead and add labels, and then we'll add our numbers because I can't remember the numbers off the top of my head. We need an FG. We need an FA. We also need an FF for force of friction. Okay, great. Higher up. All right, and I don't need a tension or a spring, so I'm going to delete those. Now let's add our values. So we need 39.2 for our force gravity. So 39.2 equals 39.2 newtons. Send it out. And I'm going to control comma to make this big again. All right, and then I know that the force applied is 55 newtons because I can see that. And then we also have a friction of 37 newtons. And we need to figure out our force normal. But lucky for us, since it's on a surface and it doesn't say anything about it moving up and down at all, we can assume that it's balanced in the vertical direction, which means we can also say that our force normal, not neutral, normal, is equal to 39.2 newtons. Great. Now let's scale our free body diagram just so it all makes sense. So 55 is the largest, so I'm going to extend this arrow out a little bit. These two should be the same length, but this arrow, 37, should be a little bit shorter than the other two, so I'm going to shorten it just a little bit. Great. That's good enough for our purposes. Save and close. Now I need to do a sum of the forces in the x direction and in the y direction. I went ahead and set up your equation so you could copy paste the symbols for our problem. Sum of the forces in the x direction, I see a force applied, and I see a force friction. Okay, so that means I'm going to plug in my values next, which means my force applied is 55 newtons. Oh, I should say minus because it's in the opposite direction. Minus 37 newtons. Okay. Paste again. So 55 minus 37, I don't believe you're doing math in your head. So 55 minus 37 is equal to 18 newtons in the x direction. Great, we're going to need that. Let's go ahead and do the y direction. So in the y direction, our forces are normal pointing up and gravity pointing down. So F, oops, wrong one, N minus Fg, because gravity points down. So I'll copy and paste. I'll plug in my values, 39.2 newtons minus 39.2 newtons, which that's just going to equal 0. Great. It's basically make it easier. Awesome. So now we've done our net force calculations. Now we're going to go over to our Newton's second law application. So now we're going to start with knowing the fact that our net force equals mass times acceleration. I'm going to go ahead and do both the x direction and the y direction just so you can see how it works. But for this problem, it's actually only asking for the x direction. And I think for your assignment, you're only asked for one direction in any problem. So let's do the y direction first. So I'm going to start off by saying some of the forces in the y direction is equal to mass times acceleration. And then I'm going to say that my, instead of writing that sigma again, I'm going to plug in my value. So I know my sum of the forces in the y direction is 0 newtons, and that is equal to my mass, which is 4 kilograms, times my acceleration. So because 0 has to equal 0, I know that my acceleration in the y direction has to equal, oh, I don't want that. Acceleration in the y direction has to equal 0 meters per second, or meters per second squared, because 0 on one side of the equation has to equal 0 on the other. Okay? So if you're seeing a balanced free body diagram like we do here in the y direction, that means your acceleration should be 0, right? Just wanted to show you all that. Now let's do it in the x direction like the problem actually asks us to. So I'm just going to copy paste some of the forces in the x direction equal to. We're going to say mass times acceleration. And I'm going to go ahead and add in the x direction, not in the y direction up here, just so I remember that when I look at my directions, I look at them separately, just like we did in projectile motion. Okay? Sum of the forces in the x direction, I have a value for that. That's 18 newtons. That's going to be equal to my mass, which is 4 kilograms, times my acceleration in the x direction. So that means that my acceleration in the x direction must equal, to solve, it's got to be 18 divided by 4, right? I want to get that a by itself, so I got to move my 4 to the other side. So 18 newtons. Oh my goodness gracious. What's technology, they said? It'll be fabulous, they said. Okay, equals 18 newtons divided by 4 kilograms, which means that my final acceleration is 18 divided by 4, which is 4.5 meters per second per second. Great. We made sure to keep up with our negatives and positives over here. So the fact that it is a positive value makes sense. If we're pushing it and it's moving forward, then we would anticipate our acceleration to be positive. Because if we're pushing in the positive direction, it's moving in the positive direction, it should be speeding up. That makes sense. Okay, that is your process for solving for acceleration. Let's look at number 2. This time we're going to be asked to solve for mass. So we're still actually going to end up using the same formulas we did before, the fact that force is mass times acceleration, but we got to do the other grunt work first. So we have in our problem, 68.6 Newton box is slowing down, okay, that's important, with a constant acceleration of negative 4.5 meters per second as it slides along a rough surface. Rough means there's friction. The force of friction between the box and the floor is 15.2 newtons. What is the mass of the box in kilograms? Free body diagram first. So we have a box slowing down, we have a friction. It doesn't say anything about being pushed, so it's not being pushed. We don't have a force applied. It is on a surface though, so there should be a force normal. And we are on Earth, so there should be a force of gravity. So let's go ahead and set up our free body diagram just with that information. I've got a force normal going up. I've got a force gravity going down. Okay. And we can go ahead and put in our value for force gravity because that 68.2 newtons we see over here, that is the same as the weight of your object, which is your force gravity. So equals 68.2 newtons. And since it's balanced in the vertical direction, it doesn't say anything about it accelerating upward or downward. It's not falling, it's not sinking, anything like that. Then we should be able to apply that 68.2 newtons up here for our force normal as well. Okay. And then we have a friction. And our friction is 15.2 newtons. So we definitely want a much shorter arrow, like at least third the size. There we go. And that is our force friction. Is equal to 2.2 newtons. Did I get that right? 15.2? Yes. Okay, great. So now I've got a free body diagram. We can do X direction and Y direction. X direction is more interesting. We'll start there. That is just equal to our force due to friction. There's no other forces. But since it's pointing in the negative direction, it's going to be a negative value. This is something that a lot of y'all messed up on our previous practice, is that you wouldn't remember that even though there's only that one force, it's still negative. Got to keep track of those negatives. So I can copy and paste. So now I can put in my value. Since it's backwards, it is a negative 15.2 newtons, and that is our net force in the X direction, easy peasy. In the Y direction, we have force normal pointing up, gravity pointing down. So F N minus F G. Paste. We can plug in our value, which is 68.2 minus 68.2 newtons, which means that it should just be 0 newtons. Okay, leave a line to separate, make it easier. All right, now we can find our mass. So we're going to start with our same sum of the forces is equal to mass times acceleration. The reason I picked the X direction is because that's where I actually have an acceleration that I can use in this formula. If I don't have the information, I can't solve the problem. So we're going to say X equals mass times acceleration. And then we want to make sure that we're thinking in the X direction. Since I'm looking for mass, I need to rearrange this formula. So instead, I'm going to take that AX, divide it to the other side. So I'm going to be left with mass is equal to mass equal to sum of the forces in the X direction divided by our acceleration in the X direction. Okay? Divide to the other side, divide to the other side. That's how I got that. Now we can plug in our values. So mass is equal to, my sum of the forces is in the X direction is at negative 15.2. Remember, you have to put in the negative. Gotta do that. Negative 15.2 newtons. And I'm going to divide that, so it's easy to see. Divide that by my acceleration, which we see over here is negative 4.5 4.5 meters per second. Remember, put in your negatives. Negative 4.5 meters per second. Now we can do our calculation, and we'll see that 15.2 divided by 4.5 is 3.38. I rounded. 3.38 kilograms. Whew, we did it. All right. The reason my number came up positive is because I kept track of my negatives. Negative 15.2 divided by negative 4.5 is going to yield me a positive value. Keep track of your negatives. Okay. I know this is a lot of information, but this half you've all seen before. So the main focus is that you need to know to start with sum of your forces is equal to mass times acceleration. Make sure you pick your correct direction. Do some one-step algebra, and you can get there. Email me if you have questions, okay? All right. Oh, I remember now. Okay, y'all have a good day.